Section 7.6, Deployment Pipeline, Validate Kubernetes Manifests. Chapter 3 introduced the concept of a deployment pipeline and its importance in the continuous delivery approach for delivering software quickly, reliably, and safely. So far, we've automated the first part of a deployment pipeline, the commit stage. After a developer commits new code to the mainline, this stage goes through build, unit tests, integration tests, static code analysis, and packaging. At the end of this stage, an executable application artifact is published to an artifact repository. That is a release candidate. In this chapter, you learned how to deploy Spring Boot applications on Kubernetes using a declarative approach based on resource manifests. They are fundamental to a successful deployment of the release candidate on Kubernetes, so we should guarantee their correctness. This section will show you how to validate Kubernetes manifests as part of the commit stage. Section 7.6.1, Validating Kubernetes Manifests in the Commit Stage. Throughout this chapter, we've worked with resource manifests for creating deployments and services in a Kubernetes cluster. A manifest is a specification of a Kubernetes API object in JSON or YAML format. It specifies the desired state of an object that Kubernetes will maintain when you apply the manifest. See this link. Since a manifest specifies the desired state of an object, we should ensure that our specification complies with the API exposed by Kubernetes. It's a good idea to automate this validation in the commit stage of a deployment pipeline to get fast feedback in case of errors, rather than waiting until the acceptance stage, where we need to use those manifests to deploy the application in a Kubernetes cluster. Figure 7.15 illustrates the main steps of the commit stage after including the validation of Kubernetes manifests.
Figure 7.15. When Kubernetes manifests are included in the application repository, a new step in the commit stage is included to validate them.
There are several ways of validating Kubernetes manifests against the Kubernetes API. We'll use kubeval, www.kubeval.com, an open-source tool. You can find information about how to install it in Section A.4 of Appendix A. Let's see how it works. Open a terminal window and navigate to the root folder of your catalog service project, catalog service. Then use the kubeval command to validate the Kubernetes manifests within the K8s directory, dk8s. The -- strict flag disallows adding additional properties not defined in the object schema.
See this code?
In the next section, you'll see how to use kubeval in the commit stage workflow we implemented with GitHub Actions. Section 7.6.2, Automating Kubernetes Manifest Validation with GitHub Actions. GitHub Actions is the workflow engine we use to implement the commit stage for the catalog services deployment pipeline. Let's extend it to include the Kubernetes manifest validation step, as illustrated in Figure 7.15. Go to your catalog service project, catalog service, and open the commitstage.yml file within the .github/workflows folder. To implement the validation step, we'll rely on an action built by Stefan Proden. He's the maintainer of FluxCD, a CNCF incubating project providing a continuous deployment solution on Kubernetes based on the GitOps principles. The action lets you install specific versions of useful Kubernetes-related tools. We'll configure the action to install kubectl and kubeval.
Listing 7.7, Validating the Kubernetes manifests for catalog service.
After updating the commitstage.yml file with the additional validation step, you can commit and push your changes to your catalog service repository on GitHub and verify that the commit stage workflow completes successfully, meaning what you included in the manifests is compliant with the Kubernetes API. Polar Labs. Feel free to apply what you learned in this chapter to config service and prepare the application for deployment. 1. Configure graceful shutdown and a grace period for the application. 2. Write the deployment and service manifests for deploying config service to a Kubernetes cluster. 3. Update the commit stage of the deployment pipeline for config service to validate the Kubernetes manifests. 4. Configure the catalog service deployment with the config service URL via the spring_config_config_URI environment variable, relying on the Kubernetes native service discovery feature. 5. Configure Tilt to automate the config service deployment to your local Kubernetes cluster bootstrapped with Minikube. When you're done, try deploying all the components of the Polar Bookshop system we've built so far, and check their status in Octant. You can refer to the Chapter 07/07N folder in the code repository accompanying the book to check the final result. See this link. Congratulations!